Okay, so we are going to be doing the review on gases and solutions. So first we will cover all the details of the solutions and then we will look at the gases. So first of all, important things that you need to absolutely know from the, in the solutions chapter is number one, solubility of ionic compounds. So know how to use the table of solubility. We have covered that, many times, but that table shows you some of the polyatomic ions, which when meet, which when connect with a metal, will create a compound that is either soluble or insoluble. So we know that the solubles are always written as AQ. So all the solubles are AQ, and the insoluble ones we express as solid. So that is where the students get confused. They think that S stands for the S stands for like solid, but S actually, no, X stands for soluble, but X actually stands for solid. And solid, the other name for solid is precipitate, Precipitate. So if the question asks, like if the question says that, okay, tell whether the substance is soluble or will form a precipitate or not. So this is precipitate means that it is insoluble. Okay, so insoluble in aqueous medium. Aqueous means in water, insoluble in water. Okay, and then if something is soluble, it's aqueous. So AQ is for soluble in water. So ionic compounds, we look at the water, okay? So anyways, so when you look at the table, you will see, look at the sulfates, look at phosphates, look at nitrates, right? Chlorides, bromide, iodides, hydroxides, right? And then barium, strontium, calcium. So barium, strontium, and calcium, these guys are very specific, right? When majority of them are following like some rule, and lead also, but lead in +2 state, lead +2. So all of them are +2. So these guys will be like kind of like either insoluble or partially soluble. So keep that in mind about the barium, strontium, calcium. So if every other element is soluble, they will be insoluble. So it's like that with these guys. Okay. So anyway, so another thing, so we can do more practice on this later, but for now, the way to do is you should just, like I said, just look at the table, look at the polyatomic ion, or look at the anion, right? Anion such as a chloride. So chloride, bromide, iodide, when they mix with another metal, will they be soluble or insoluble? So those things. And here you have the ammonium and you have the hydroxide also. But anytime ammonium and group 1A is with anytime ammonium is with a polyatomic ion, or any non-metal, or like group 1A elements and ammonium, they make things soluble. Okay, the rest of it is just use the table. Okay, let's move ahead. Next, we are looking at the solubility of covalent compounds are molecular compounds. Molecular compounds, like the ones that contain lots of carbon-carbon bonds, or carbon and hydrogen bond. So here the rule is like dissolves like. So here you are going to look at whether something is polar or whether something is non-polar. So polar, or non-polar. So those are the main, identifiers. So polar and polar will mix, and non-polar and non-polar will mix. So here you have, so water is always going to be polar. Keep that in mind. Water is always polar. Water is always polar. And now we have to look at whether the other substance is polar or not. So here we are looking at the polarity of water. I mean, whether this substance is going to mix in water or not, or whether this substance is going to mix in oil or not. So not oil, just look at all the oils, creams, grease, all those things are non-polar. Okay, so CH3OH. So here, remember that CH3 is non-polar. This site is non-polar. But anytime there is one end is non-polar, the other end here OH, polar. How do you know that this is polar? Because OH is always going to be a polar end. Same is the case here. You see this COOH. So COOH, anytime you have this COOH, it will be polar. Okay. So CH3 side is always going to be non-polar. Okay. So here this is non-polar end. Non-polar, but you have the other end, which is this side. This is polar. Okay. All right. Next is, we are going to look at whether the CH3OH is soluble in water or it is soluble in oil. So we see that this is soluble in water because that's a polar compound. And oil is non-polar, so it will not dissolve in water. Okay. Next is C2H6. Remember, anytime you have lots of carbon hydrogen bond, no oxygen, no nitrogen, no fluorine, chlorine, bromine, those are like electronegative elements. That means this molecule, all the CH bonds are non-polar. Okay, so this is not going to dissolve in water, but it is going to dissolve in oil. Similarly, CH3, COOH, polar end, CH3, non-polar end. So this molecule is polar. So it is going to be soluble in water. And then non-polar, oil, it will not dissolve in oil, even though it has one side is non-polar, but the other side is polar. So overall, the molecule becomes polar. Anytime there's one side is polar, the overall becomes non-polar. Okay, the rest is ionic. So ionic compounds, as we talked about, the rules are in that solubility table, which, the more you do it, then you start memorizing it. Okay. So that's the very basic thing about. So you have to, what are you going to look at? You are going to look at whether, like I said, whether you have molecules like in the molecules, is there oxygen? Is there nitrogen? Is there fluorine, chlorine, bromine, iodine, right? So these things make, any time when they are in a molecule, they bring polarity. So this becomes polar. Polarity comes in a molecule because they are very electronegative elements. So remember that. Okay. So a polarity is induced. Dipole, you remember that you read that dipole about the intermolecular forces. So these intermolecular forces, we know that they're a dipole, what is going to be in the dipole? So dipole, there is going to be, like I said, oxygen, nitrogen, then fluorine, chlorine, bromine, and iodine. Okay, these guys are always going to induce polarity in the molecule. So that's what makes dipole. Dipole means two poles, polarity. Okay, polarity induced because of the presence of these. And yeah, molecule becomes polar. So then you're going to see if the molecule is polar, will it dissolve in, like if it has a dipole, is it going to dissolve in polar or not polar solvent? Yes, it will. But if it is non-polar, it is not going to be soluble. Okay. Anytime there is a dipole in the molecule. So same thing here that we discussed. This molecule, there is a dipole here. This CH3OH has a dipole. So one end is non-polar, the other is polar. Similarly, there is a dipole here. One end is polar, the other is non-polar. Okay. So that's one thing. Next is the London dispersion forces. Now, this is present in all molecules. So this is just the spread of electron cloud, spread of electron cloud. And spread of electron cloud means that, it's like mostly like oils, grease, like that spread. So it's that. So it's present in all molecules. So pretty much leave. But hydrogen bonding is important because hydrogen bonding creates a positive side polarity in a molecule, positive side here, more electronegative oxygen, more electronegative nitrogen, more electronegative fluorine. So oxygen, nitrogen, and fluorine, all these have the electronegativities are very high. The electron affinity is very high. Electron affinity, love for electrons is very high, right? So, and then they have the lone pairs which participate. So hydrogen bonding occurs between the two different molecules. Okay. So that also causes, that creates a network. Okay. Network. So that creates a network which, these are very, very weak attractive forces. Nonetheless, they influence the physical and the chemical properties. So physical properties very specifically because of hydrogen bonding water boils water. The boiling point of water is very high. Boiling point of water is equal to 100. And if you compare H2S versus H2O, so you will see that the H2S exists as a gas, but H2O exists as a liquid, and this is because of hydrogen bonding. H2S does not have hydrogen bonding. Hydrogen bonding is only present in water, okay, where there is, oxygen attached to hydrogen. H, O, H. So oxygen is attached to hydrogen. So that creates that is what makes it, a very polar molecule. So just look at that. Okay. Next is the balancing reactions and looking at the solubility, total ionic, net ionic, and the spectator ions. Now, here we are going to identify the products. So we have calcium nitrate and sodium phosphate. So remember that. Here, identify the calcium and the sodium formula. So we know that this is group 2A. So therefore, group 2A, therefore plus 2 charge. This is group 2A, therefore group 1A, sorry, group 1A, therefore plus 1 charge on sodium, right? And nitrate, it's kind of standard charges. I asked you to memorize these, but if you have not, then you should. And then also make sure you consult the handout on the exams in case you forget if it was -1 or -2 charge or +1 charge, those things. So you cannot go wrong. So when you're doing your homework or you're practicing, you must keep looking at the handout so you know where to look for in the exam. Anyways, so here you have now here group 2A +2 charge and nitrate -1 charge. Now, they obviously they're going to crisscross now. So calcium is going to combine to phosphate and sodium combines with nitrate. So what are the products? The products are calcium phosphate and sodium nitrate. How do you write the right formula? So you write the right formula. Calcium is +2 charge, phosphate is -3 charge. Just crisscross, because 2 is more than 1, therefore phosphate is put in 2 is more than 1, therefore phosphate goes in brackets. You put it like this, okay? PO4 -2. So I should write this in different. Like that, okay? And then comes the sodium nitrate. So in this case, sodium nitrate, also sodium +1 charge, nitrate -1 charge, and that is +1 charge, they cancel out. So then what happens when they cancel out? They just don't, then you just write down the formula as sodium nitrate, like this at the bottom. The rest is balancing. Now, here's the thing with the balancing. When you're balancing, it is okay not to put charges, because the problem with that is sometimes students get so much confused or engrossed in just the charges that they start making mistakes. So best is just forget the charges, just keep it at the atomic level. So calcium, there is only one calcium initially, right? There are 3 sodiums initially. There are 2 nitrates. Keep the polyatomic ions together. So there are 2 nitrates initially, okay? Now we have, on the other hand, there is 1 sodium and there is 1 phosphate, okay? On the other hand, we have 3 calciums and we have 2 phosphate. We have 1 sodium and 1 nitrate. So sodium is obviously not balanced, phosphate is not balanced, and even calcium is not balanced, and nitrate is not balanced. So everything is, so you can pretty much start from anywhere. But let's start from something obvious. There are 3 calciums. So if you put 3 in front here, then it's a good thing. Then if you put 3 here, right? So that makes the multiply by 3, and that gives you 3 calciums and 3 nitrates. So balancing, pretty much, you will have to come through practicing. And on the other hand, if you look at the, now if you look at the nitrates are 6, so we can easily make nitrate 6 here by putting 6 in front of sodium nitrate. So that 6 now has to be multiplied. So 1 multiplied by 6, That gives you 6 sodiums and 6 nitrates. So these are balanced. Now look at sodium. Sodium is 6 sodiums, but on the other side, we have only 3 sodiums. So what are we going to do? We're going to put a coefficient of 2. So that means 2 multiplied by 3 and 2 multiplied by 1. So that makes 6 sodiums, and that gives you 2 phosphates. And now if you balance it, it balances out. Everything balances out correctly. So we have 3 sodiums. We have 3 sodiums, 6 nitrates, 6 nitrates, 3 calciums, 6 nitrates, 6 nitrates, and 2 phosphates, 2 phosphates, 6 sodium, 6 sodium. Everything is balanced now. Okay. So that's the balancing. Now comes the charging. Now here's the thing with the total charging. Majority of the battle is won. Now you just have to add charges. That's it. So we have in this overall, we have 3 calciums, right? Just put the charge here. 3 calcium plus 2 charge. Okay, let's look at it here. We have 6 nitrates here, right? And here you have 6 nitrates plus minus 1 charge. We have 6 sodiums. So students are able to balance. That's the thing. Interesting thing is students are able to balance. Now in the next, they just have to put the charge. So 6 sodium is plus 1 charge. And here you have 6 nitrates. So now just put it 6 nitrates here. Okay. Then you have 6 sodiums here, right? And then just put 6 sodium with plus 1 charge. Same thing, nothing different. 2 phosphates, now just put the charge plus minus 3, okay? And then you have 3 calciums, right? Now, here's an interesting thing. Important thing to remember is that the substances that do not like that are forming a solid, when that's why it's important to know the solubility of these. So nitrates are soluble to calcium nitrate soluble, therefore each of these will be this is aqueous, this is aqueous. Similarly, sodium phosphate is soluble by default of sodium being soluble in water, so phosphate also becomes soluble in water. Then here you have sodium soluble in water and nitrate soluble in water. But the thing that is not soluble in water is the calcium phosphate. Therefore, you put it as a solid. So do not ionize solids. Excuse me. Okay. Now, the net ionic. A net ionic, we write down only ions that show change of state. So which ions show the change of state? So we see calcium going from calcium like aqueous and phosphate aqueous to a solid state. So here we have the calcium aqueous, phosphate aqueous, and here you have the solid. Okay, so only these guys. And which are the spectator ions? The ones that ions that show the change of state. So ions that do not show change of state. Okay, so that's one. Next is the reaction stoichiometry. Now reaction, this is all these questions are going to be on the test. So here you are given an acid and a base, and you're making a salt and water. So you're making a titration. This is a titration experiment. Somewhere the question will say titration. So anyways, so you have to look at it, what is given to you. So you are given here the molarity and you are given the volume. So this is the value of molarity, this is the volume. Okay, so you are being asked, and here you are given the volume, but you're being asked to find the molarity. Okay, so base is base, and A is the acid. So one way to keep it like this is that way. So always convert milliliters to liters. How do you do that? 1 liter is equal to 1000 milliliters. So basically, what do? You take the milliliter, given milliliter, and you multiply that by 1 liter over 1000 milliliter. And that should give you the answer in liters. Okay, so you bring that. Next is find the moles of the base. Everything is about the moles now in stoichiometry. So find the moles of the base. How do you find the moles of the base? This is the formula. So you should write down the scheme, on your handout, write down the scheme so that you can just follow the scheme. So the number of moles is equal to molarity times the volume in liters. Okay, so this will give you the moles of the base. Next is you're going to find the moles of the acid. So same story. How do you find the moles of the acid? You take the moles of the base that you calculated from the top, divide by the mole to mole ratio that is in the balanced equation between the acids and base. So you're just going to put the coefficients. Okay, put the coefficient. So coefficient of the acid on the top and the coefficient of base at the bottom, and that gives you the moles of the acid. Next is just take the moles of the acid, divide by the volume of the acid. So always make sure that these milliliters also get converted. These milliliters all can converted. You need it here. Okay. Moles of the acid divided by the volume gives the molarity of the acid. So I'm just letting you know there is going to be a question here. So you should know the I mean, this is a review, so important, all the test questions pretty much are going to be there, but just make sure you master this one. Okay, don't get confused on this. So just follow this scheme, you should be fine. Okay, next is, and also, right now I have given the question so you guys can practice it on your own also on the side. I've not done the practice. So if you should do it on your own. Okay. Next is if you are given the molarity and you are given the volume in milliliter, find the number of grams of the other reactant. Okay. So you are given the molarity and the volume. So always, always, always first thing is to convert the milliliters to liters. Okay. Now here you are for reactant. So this is reactant one. This is reactant two. Okay. This is the product and this is another product. Okay, so here for the acid, like I said, I'm using acid A and B is for the base and R for the reactant. Okay, just for the short case. So here, first is convert the milliliters to liters. Then using this formula, the number of moles is equal to molarity times moles is equal to molarity times volume. Then you take the of the acid, moles of the acid, you find the moles of the acid, you take the molarity, you times it by volume. Okay. Next, you get the moles of the reactant, which is the other, entity. So moles of the reactant is you take the moles of the acid, this one that you find from here, multiply by the mole to mole ratio. So this is always mole to mole ratio from the balanced equation. Okay, and that gives you the moles of the reactant. Next is the moles of the reactant. You convert them to grams of the reactant because that's the question is. And for that, you would need a molar mass of the reactant. Okay, so this has been done, I believe. Yeah, so this I did for you guys, so you can double check this one. Okay, next is all the concentration problems. So these are just understanding a few things. How do you make sense of something that is written as 25% or some percentage, 10%, 5%? What is the meaning of that? It means that whatever amount is there, percentage of remember, this is the solute. This piece is the solute that is making the this a whole solution, and generally these solutions are in water. Okay, but here is a rubbing alcohol which is a solute, so that's why it is, so it means 25 milliliters. And if it is says, let's say this one is volume by volume, so 25% volume by volume percent, so that is why we have milliliters and milliliters. But if it was 25 grams, 25% grams by grams, then we would just, instead of milliliters, you replace that with liters. So, so let me put this here. If it was mass by mass percent, then then you use grams. Then use grams by grams. Okay. So, but in this case, we are using milliliters. So just find that. So because the solution, they have given the volume of the solution is 500 milliliters. And the rubbing alcohol is 25%. So what is the meaning of that 25%? Means 25 ml of rubbing alcohol is present in 100 milliliter of solution. Then we can create the conversion factors. Okay, so 25 ml alcohol over 100 ml solution, or 100 ml solution over 25 ml alcohol. Okay, so just write down what is given to you. This is given. 500 ml solution is given, times you need to find how much alcohol is present in 500 ml solution. So 100 ml solution and milliliter solution cancel out, and 500 times 25 gives you 125. So this is how you will solve this problem, a percentage problem. Now, on the other hand, let's just put this here. This is on the side. Okay. Now, on the other hand, if you are given the mass by volume, so in that case, you can't change much. Volume means 100 ml of the solution. Okay. So in that case, the conversion factors become like this, that fit 5 grams of whatever solution is there. It could be the sugar solution, NaCl solution, potassium nitrate solution, glucose solution, whatever, doesn't matter. But remember that the solutions are always, the reference is always the solute. So we know what is in there inside the solution. Okay, so we have here 5 grams of NaCl over 100 ml of the solution, or 100 ml of the solution over 5 grams. These are the conversion factors. Now the question is, how many grams of sodium chloride are needed to prepare 200 ml of 5% mass by volume NaCl solution? So, you have to, like, these are all technical, like, writings, and sometimes when you are reading them, sometimes it doesn't click right away, but start putting in all the information that is given to you. Start putting it on one side. So this means that you are preparing a sodium chloride solution, right? And how many, you need to prepare sodium, you need to know how many grams of sodium chloride are needed, right? And you want to prepare 5% mass by volume solution. And the total volume of that solution is 200 ml. So this is what it means. So 200 ml is what we want, or kind of like what is given to you. So the solution that, we want if we take 5 grams of sodium chloride and we put it in 100 milliliter of the solution, then we will get 5% mass by volume. But for 200, how much you would need? So you set the problem like this. Okay. So 5% again has been made into those two conversion factors. So it's fairly easy, but just, all this is going to be on the exams now, on the test, if either not this, on the final exam. Okay, mass by volume percent. Mass by volume is again grams by grams. So remember that grams of the solution. So read the question. If it says water, that means we are looking at the solvent. So we are given 100 grams of water, so don't use it as a solution. So mass by mass, you are going to add. The glucose is a solute and water is the solvent. So solute plus solvent gives you the solution. Okay. So you take the 10 grams of the glucose over 110 grams of the solution times 100%. So 9%. So this is how you get it. Okay. Next is find the molarity. So you will be given some ionic compound or some covalent compound, right? Some grams of it will be given, volume will be given, and you will be saying find the molarity. So we know the formula. Always write the formula. Molarity is what? Molarity is moles over liters, volume in liters, okay? Moles over volume in liter. So we are given 750 milliliters. We need to convert that into liters, okay? So that's one piece we will do. Next is we need to find, because moles, we are given the grams, we are going to convert the grams to moles. And how are you going to convert the grams to moles? You're going to find the molar mass. So take the grams times moles, divide by the molar mass. So this is kind of a standard gram to mole conversion formula. So you will be, in this case, this is an important question because it allows us to test whether the student can calculate the molar mass or not. Okay, so those things. And then next is find the final freezing point or the boiling point. So just remember that free. So generally for this thing, we are only using water as our solvent. Okay. So here in this case, so the solution of, one second, let me put this here, the solution of water. So in that case, we will take the boiling point of water, 100 degrees Celsius, and the freezing point of water is 0. Okay, so this is known. This is like, so these are, that is why these are the initial values, T initial values. Okay, so now, like I told you, the formula given in the book is not correct. So make sure you write the right formula, which is I have shown you here. The change in temperature, if we are talking about the freezing point, you use the delta TF. If you're looking at boiling point, you use the delta TB. Okay, now very important is the value of I, which is missing from the book. So always remember that for ionic compounds, the value of I is how many ions are going to be liberated in the solution. So sodium chloride will give you 2 ions, sodium and chlorine, right? And magnesium chloride will give you 3 ions, magnesium and magnesium and 2 chlorines. So that makes it 3. And then if you have a covalent compound, the one that contains like lots of carbon, hydrogen bond, in that case, it is 1. Okay, so calculate for the ionic compounds. I for the ionic compounds is equal to the number of ions, and for the covalent compounds, we just write 1. Okay, so these two differences. Now the value of Kb and Kf is going to be given to you, so don't worry about that. Now, all you're trying to find is now just plug those values in. Kb and Kf value will be given to you. Write that down. You figure out if it's ionic, you write down how many ions. If it is covalent, it's just 1. Covalent means like the ones that contain lots of like sugar, right? Sugar commonly, right, is a covalent compound. Okay, and then M dash. M dash is the molality. So what is the molality? You will be given the moles of the solute divided by the kilograms of the solvent. It will be just given to you. Kilograms of solvent is generally, like I said, water. So kilograms of water divide by like moles, and then you put that. So, but remember that this gives you the change in temperature. But the question will say find the final volume. So how do you find the final volume? So final volume is so T final is equal to the T initial, okay, T initial plus the delta T B value, okay. So final temperature is whatever the initial temperature is, and you add the change in temperature. That's the final temperature. B or F also, okay. So that kind of question. So next is the theory, right? The theory, like you should know what is a solvation of ions. Solvation of ions is also called a hydration of ions. So just look at the lecture notes. Hydration and solvation means that every anion surrounds the cation and every cation surrounds the anion. Okay, so that's one thing. Next is the solubility of gases, whether the gases are soluble in water or not. So the gases, remember that as the temperature increases, the solubility of solids go down. As the temperature goes down, the solubility of gases increases. So it is very important you know this difference. Solids, it's opposite. Temperature increases, solubility increases. But gases, it's opposite. Okay. Same story with pressure. As the pressure increases, the solubility increases. As the pressure goes down, solubility goes down. Okay. So that's thing. Next is about the electrolytes, whether something is, electrolytes are like the ones that the bulb glows, when the light is passed through a solution. So it's about, it all relates to the solubility of ions. So if something is soluble in water, it will conduct electricity. If something is insoluble or partially soluble in water, it will be a weak electrolyte. Insoluble will be a non-electrolyte. So always remember, insoluble ones are carbon, hydrogen. These will always like, no, oh no, wait, I'm not going to say they are insoluble, but they are not going to conduct electricity. The carbon and hydrogen containing compounds, they may be polar, they may be soluble in water, but they are always non-conductors of electricity. Okay, non-conductors. All right, so this is just one piece. The rest you have to see that, whether they are, so if they are partially ionizing, the trick is that they will show the, you will see this sign, the equilibrium sign, partial. That's less than 100% ionization. Okay, so just to give you an idea, so sorry, so CH3COOH, this is vinegar. So this is partially soluble. Okay, so this will be a weak conductor, weak electrolyte, just to give you an idea. Solubility, and these guys, they like, for example, HCl, like NaOH, right? These are very, very strong electrolytes, like HNO3. They're strong electrolytes. Okay. Okay, next is the boiling point of water. You should know is 100, but it's only at the plains, when it's 1 atm. But on the hills, the water boils fast because there is low pressure. And on the seaside, the water takes longer to boil because of the high pressure. So the relationship between the pressure and the boiling point, right? And those things. Okay, next is the vapor pressure of the solutions. What is that? So we know this is one of the colligative properties, that the vapor pressure gets lowered. For the solutions, the vapor pressure is lowered. Okay. Vapor pressure for the solution is lowered because the water, if it cannot boil fast. So here you are trying to boil water, right? And here's the thermometer, degree Celsius. So the water is being trapped by the solute particles in either the intermolecular forces or like the solvation of ions, they're soluble. So the water molecules are not available to escape. Therefore, vapors on the top surface of the liquids, these are called, they exert their own pressure. These are called a vapor pressure. And so this vapor pressure causes the liquid, or like it causes the solution to boil, to take longer to boil. Okay, so we call, so the solutions boiling point is, it's going to take longer to boil, means then the boiling point is high and the freezing point is low. So these are the colligative properties. Okay, so that's one thing. Now gas laws, we can do the gas laws on a separate, yeah, I can do the gas laws, specific questions from the gas law. But from the solutions, do you guys have any questions? Any specific questions? Okay, let's do one thing. Let's just, for your practice, let's do this. I'll give you some questions so you can practice first, and then let's see if you guys can do it. So practice, and I'll give you like some time you do on your own. Okay, so here, practice. Okay, so here is a solution, here is a reaction, number one. Okay, so here I'm going to give you, this is, let's just do this here, 10 ml, no, not 10 ml, sorry. 25 milliliters of NaOH, and it is 5 milliliters of NaOH, 5 molar. So the volume is given and molarity is given. And this is a base. So this is the base, okay? And you find the molarity of the acid when you are given the volume is 20 ml. Okay. So find the molarity. So find the molarity of this acid. Okay, so I'm going to, so this is one question. Okay, so you guys have, yeah. So this is one. The next is, okay, you are given like iron as a solid reacting with H3PO4. This is the aqueous, this is the, so this gives you Fe3PO4 whole twice plus H2O. So 3, sorry, H3PO4 and Fe, or let's do this here. This may not work. FePO4. Okay, and water. Okay, so here you are going to find find the grams of iron when you are given the molarity is 5 molar and the volume is 50 molar, 50 ml. Okay, so just make sure that everything is balanced out. Yeah, balance. First balance. The first one I already did. Okay. And then the second one is this. So these are the two questions you guys should be doing. I'm going to just stop recording for now, and then we will come back. I'll give you about 5 minutes, 10 minutes time. Do you guys, should I put you in breakout room so you guys can congregate with each other? Should we do that? All right, so now we're going to start these. So here we have, okay, so the first step is always convert the milliliters to liters. So we have about 25 ml from the base, right? Times 1 liter over 1000 milliliter. And that gives you 0.025 liters of the ammonium hydroxide. This is the volume of the base. Next is for the same story is for the acid, which is 20 milliliters times 1 liter over 1000 milliliter. And this gives you 0.020 liters, and this is the volume of the acid. Okay, so one piece. Second thing is find the moles of the base. So moles of the base is equal to the molarity of the base times the volume in liters of the base. So here we have the molarity is 5 molar times the 0.025 liters, and this gives you 5 times 0.025, and that gives you 0.125 moles. So these are the moles of NH4OH, which is the base here. Okay, now third step is find the moles of the acid, which is H2SO4. So how do we do that? We take the moles of the base, which is 0.125 moles, and these are the moles of NH4OH, right? Times the mole to mole ratio. That is why balancing was important. So we see that 1 mole of H2SO4 is reacting with, sorry, 1 mole of H2SO4 H2SO4 is reacting with 2 moles of NH4OH. Okay, and so here you get, so 0.125 times 1 divide by 2, and that gives you 0.0625. These are the moles of H2SO4, which is the acid. Okay, next is we need to find the molarity. So we know the molarity is equal to moles of the acid divided by the volume in liters of the acid. So the moles is 0.0625 moles of H2SO4, and that is divided by the volume. The volume of the acid is 0.020 liters. Okay, so 0.0625 divided by 0.020 liters, and that gives you is equal to 3.125 m, and this can also be 3.13 m. So that's the correct answer. Okay, everybody get that? That's the molarity of H2SO4. So that's one piece. Okay, that's done. Next, let's look at this one. Iron is reacting with phosphoric acid to give you iron phosphate and hydrogen gas. Okay. Now here we are going to look at the balancing. So 3 hydrogens, 2 hydrogens. So if you put 2 here and you put 3 here, that makes 6 hydrogens. But that makes, so there are 6 hydrogens, right? 6 hydrogens. But then this 2 also applies to phosphate. So that means there are 2 phosphates. So now you're going to put 2 here and you're going to put 2 here. So 2 phosphates, 2 irons, and 2 phosphates, and 2 phosphates. So yeah, so 2 irons, 2 phosphates. So 2 irons. Everybody balanced it like this? Everybody balanced it?
Yes,
Yes?
ma'am.
Good. All right. So now it's the opposite. Now we are given the base acid, and we are being trying to we need to find the grams of the metal, right? So here you can easily find the moles. The moles of this acid is equal to molarity of the acid times the volume of the acid. Okay, so same story here also. First we are going to convert the milliliters to liters always. So 50 milliliters times 1 liter over 1000 milliliters, and that gives you 0.050 liters. Okay, so that's one thing. Second thing is the moles of H3PO4 is equal to molarity of H acid times the volume in acid, and that gives you molarity is 5m times the volume is 0.050 liters. So let's do this. 5 times 0.050, and that gives you 0.25 um, moles. Okay, and these are the moles of H3PO4. All right, next is moles of H3PO4, and we need to find the moles of iron. Moles of iron, how do you find them? You take the moles of H3PO4, multiply that by the mole to mole ratio. So 2 moles of iron are needed to react with 2 moles of H3PO4. So for those of them, it's the same thing. So we have 0.25 moles of H3PO4 times 2 divided by 2. So it's basically 0.25 moles of iron. You get it? So this and cancels out. So acid. So next is the last part, which is the convert the moles to grams. Okay, and that is using the molar mass of iron. So here we have 0.25 moles of iron times iron is 56. molar mass and 1 mole. So this is the molar mass of iron. So this gives you 0.25 times 56, and this gives you 14 grams of iron that is needed. All right. So this is how, you will be doing these problems, and just make sure that these are the big main ones, and the other ones I covered in the review, but there's something else I forgot, and that is, let's do this one also. And let's do this one, number 3. And here you have the problem regarding, C1 V1 is equal to C2 V2. And this also means M1 V1 is equal to M2 V2, right? And M1, now let's say you are given, let's say you want 5 molar, and you want, let's say 125 milliliters of this solution, right? And you are given let's say 12 molar, and this, how much of the volume will you take out? So this relates to dilution problem. Dilution. This is a dilution problem. Okay, so the way you will set it up, so volume will be in milliliters, so no need to change, but we need to find the V1. So V1 is equal to M2 V2 over M1. Okay, so M2 is 5 molar times V2 is 125 ml. Okay, divide that by M1. M1 is 12 molar. Okay, so multiply this. So 5 times 125, divide that by 12, and that gives you 52.08 milliliters of HCl. So let's say if this was HCl or some more concentrated solution. Okay, so this is how you will be doing this, where the question will clearly say dilution. So if the question is asking you how much water was added, how much water added, so let's say this is HCl, and you have this HCl, lower concentration, higher volume, and higher molarity, lower volume. So this is V1 is from a higher, more concentrated solution. Okay, so how much water was added? Was added to make 125 ml of 5 molar solution. So here you will have 52.08, 52.08, that HCl, and this has to be subtracted from the total 125.00 ml. So this is the total volume of the solution we want. This is the HCl that is added. HCl added. Okay, and that gives you a solution. So, and that is 72.91. Okay, milliliters water added to make 5 molar 125 ml solution. Okay, so this is all the main things about the solutions. Now let's do the on the gases. Okay, let's do the whole thing, review on gases. Okay, now, okay, let's see this. Now, regarding this, let's say if one is the, let's say if you are given, let's say 5 grams of a metal, right? You are given 5 grams of a metal, which is, let's say in this case, sodium, right? and you are adding this sodium in water, and that's producing a hydrogen gas. And we collect that hydrogen gas, and the hydrogen gas is the volume. We need to find the volume amount of the hydrogen gas that is collected in milliliters. Okay. And pressure is, let's say, at STP, at STP. Okay. So here, sodium. Actually, let's do one thing. Let me make, because this would become a very big video. So let's do for the gas laws. Let's look, I'm going to stop recording this one and then go continue to the next one. Okay. So stop recording here.